To my right, you can see I have my BK Precision 885 RLC meter. I also have my 34401A set up. So it's been running for about an hour now, so it should be quite stable. So what I'm going to do is use these two meters to measure the values inside of our little test box, and we'll be comparing those against the Preproduction 121GW. So this is with our 10 mega ohm resistor. Let's just try it with our Agilent meter. Again, this is a 0.1% resistor. So we can see it's reading 10.002 mega ohms. So this will be 1 mega ohm. Let's see if I can do the hold this time. And this is a 1% device. You can see for the Agilent it's reading 1.0002 mega ohms. This will be our 100k ohm. So it's reading 100.11k. The office is pretty hot right now. So you can see our HP meter again reading 100.003k ohms. Again, this is a 0.1% part. So let's try 10k ohms. See, that reads dead on 10k. And again, let's try that with our Agilent. .99998k ohms. This is a 1% part, obviously a little tighter than that. This is with our 1k ohm. And you can see the HP is reading 999.94 ohms. This is with the 100 ohm resistor, and you can see it's reading 100.02. And compare that with our HP at 100.03, pretty much a match. This is with a 50 ohm resistor. Again, this is 0.01%. And we can see the meter is now reading 50.00. You can see it's just a little low compared to our HP meter at 50.025 ohms. You can see just by moving those cables just a little bit, I've been able to drop the resistance just slightly. This is with a 1 ohm resistor. This is a 1% part. And you can see our HP is reading 1.011 ohms. Again, fairly close. Let's just try it with our 0.5 ohm resistor. And you can see we're reading 0.511. And again, this is with our HP meter. So fairly close, 0.526 versus 0.510. So for resistance, the meter is actually quite accurate. Again, David told me that the meter may not be in calibration, but it looks like it does a pretty good job. Again, I've damaged this meter twice now, where I've actually had to replace some of the ICs on it, amongst other parts. So for capacitance, I'm going to start with the 150 picofarads. I'm going to go ahead and zero this out. You can see it's about 10 picofarads high. See how long this meter takes to settle? So there you have it, 150 picofarads. Pretty much dead on. It's definitely not the fastest meter that I've seen. Let's just try it with our RLC meter. See, it's basically instant with this, but 151.3 picofarads. So let's try it with 1 nanofarad. So it looks like our 121 GW is reading 0.99 nanofarad. You can see with our RLC meter we're reading roughly 998 or so picofarads. Again, fairly accurate. This is with our 0.1 microfarad. And again, you can see 1.012 or so nanofarads compared to 98 nanofarads on the 121 GW. Again, fairly close. So this will be a 1 microfarad cap. Let me just show you how fast it settles out now in this range. So fairly quick, 0.991. It's probably closer to the range that people would actually use this. And again, with our RLC meter, you can see it's reading 1.000 microfarads. And this will be 10 microfarads. I have noticed with this meter, you can see if I manually range it, you can see I get 9.95. It's like the breakpoints for the actual range selection are not optimized, because they could definitely gain another digit with this. So let me just hit hold, and let's try the same thing again with our RLC meter. And you can see it's reading 10.19 microfarad versus 9.94. Again, fairly accurate. Go back to auto range. And again, this will be a 100 microfarad capacitor. And you can see it's reading 100 point nothing. Again, if I manually range this though, you can see it's reading 100.1 or 99.9. Looks like it's fairly settled right now. Alright, try the same thing with our RLC meter. I'm just going to adjust this down to 120 Hertz. And you can see we're reading 100.0. So yeah, so even though it's a pre-production meter and it may not be in calibration, it's actually quite close. Again, considering what this meter has been through. So off to the left you can see my Fluke standard. Again, this is outputting roughly 10 volts right now. You can see our HP meter is reading about 100 microvolts high right now. So what we'll do is we'll connect this up to our 121 GW. And you can see it's displaying 10.000. You can see with 1 volt we're reading 0.99997. And you can see again with the 121 GW, it's bouncing between that last count. So the last time I was testing the Preproduction 121GW, I had it attached to our new transient generator. After I made that video, I connected it up to our small transient generator, and I actually damaged the meter again at 6 kV. So I've made some additional changes to the meter, so we'll go ahead and replicate that test. So the meter as it sits right now is 100% functional. Because of the changes that I've made, we're going to start with the ESD test. So again, I'm going to apply 5 transients, positive and negative, with each mode of the meter, and again this will be a 4,000 volt direct contact discharge. And again, this generator basically mimics the IEC standard. It'll do the 4 kV in under a nanosecond, and the peak current is close to about 15 amps. Okay, so here we go. Alright, let me go ahead and functional test it. So somebody was watching one of the videos and they saw me select the 60 Hertz, and then they saw me select the period, and they were saying, okay, this is supposed to be 16.6 milliseconds instead of 1.6, and it's a bug in the meter. And they're absolutely right. And I was quick to point out to them, again, this is a pre-production meter. Again, there could be bugs in it. And really what I'm looking for this, as far as a functional test, is a baseline change. So again, I basically went through, characterized the meter, and then I'm looking for a change from that. So for example, let's say the 1K ohm resistance mode actually measured 500 ohms. I really don't care that it measured 500 ohms so much as that after I do the transient test that it doesn't go down to say 100 ohms or up to a K ohm, because that would be a change and then I would consider that a fail. So as long as it's staying at 500 ohms in the 1K ohm, I would consider that a pass. So even though this is showing, 1.6, which is obviously a problem, I consider it a pass because this is the way the meter functioned when I first received it. And this is one of the reasons Dave didn't want me to do a review of the meter. He was concerned the viewers would see some of these problems and then they would be confused by him, thinking that that's the way the meter would behave once it was released. Obviously that's not going to be the case, but it seems that this one was brought up. Let me just kind of show you what it actually does here. So again, in 60 Hertz, you can see the 1.66. Now if I go to 120 Hertz, you would expect this to be 0.8. And you can see it is. But now watch what happens is I'm going to turn off the supply to the meter. We'll let it go to 0. And then I'm going to reapply it. See that? It switched ranges and now it's at 8.3. So now I'm going to adjust it back down to 60. And you can see it goes to 1.6 again. So there's something that happens in this range. I actually wondered if it wasn't some kind of alignment problem, but I looked through the documentation that David supplied me, and that doesn't seem to be the issue. This is probably a legitimate bug, but I've gone through quite a few features of this meter. I can tell you that's not the only problem that this meter has, and I expect as they continue to develop it, they're going to iron out all those problems. So they really don't concern me a whole lot. Alright, so this generator again is strapped for just slightly over 6,000 volts right now. Again, this damaged the meter last time. I'm going to go ahead and reapply this transient, and we'll see if the meter will survive this time. Alright, that's it. Let me go ahead and functional test it. Alright, so it looks like the meter pass is functional just fine. I'm not sure how much farther I'm going to push it. I think one of the problems that I would have next is the choice for the PTCs. They're using the smaller body style for this. And with most of the multimeters that have used those smaller bodies, I've actually caused them to arc over and damage other parts of the meter. Unfortunately, like I'd said before, the meter's pretty tight on the inside. There is some circuitry on the board that isn't being used right now. They've basically got a lot of no pops, and maybe if you removed a lot of that, maybe you could add enough to maybe move some of the traces around and then change out those PTCs next and, you know, get it to survive a little bit higher. But I think this is probably about the limit of what I could push this thing, just based on my experience of, you know, blowing up so many meters. Well, a lot of you had asked about the changes, even including Dave. I actually wrote Dave after the last video I made and again walked him through basically all the changes that I'd made with it. You know, Cliff had asked me about using this Corona dope. Of course, you see me use this quite a bit. So I could understand his thinking that, yeah, I'm probably using this stuff. The voltages that I'm testing with right now don't really require it. At some point, yeah, I would probably have to put something like this in here, but you got to realize, like when I was testing that UT61E, for example, the reason I had to use this, I was actually cutting the circuit board at that point on that meter, and I was running that meter up quite a bit higher than what I'm running this one right here. So, yeah, I'm not using any Corona dope, but I thought I'd just close this out with showing you a couple of pictures of the mod so far. And again, I've explained those changes to Dave, you know, and I'm not sure if that's something that they could actually put inside the meter. You know, it would require a circuit board change, and, you know, and I probably wouldn't do it the way that I actually changed this meter. This is kind of like solving the problem with a sledgehammer, where I probably needed a ball peen hammer. Well, I think that's going to be it. Till the next video. Later.